Alright, so in this video, we're going to take a look at the different types of counting principles. A counting principle is an act to find the total number of outcomes of something occurring. So we're going to take a look at the 4 different counting principles that we will use in statistics. The multiplication principle says, if there are A ways to do one thing and B ways to do another thing, to find the total number of possible outcomes of both events occurring, you just need to multiply A by B. Let's look at a couple examples that involve just the multiplication principle. Alright, so Mark wants to go to dinner and a movie. He has 6 options of restaurants and 7 different movies to choose from. And how many ways can Mark spend his evening? So here, the multiplication principle says we list out how many different options for each. So he has 6 options for a movie, and after each of those options, you have 7 different movies to choose from. So we will multiply the total options of dinner times the total options of movies. So that means that he has 42 different ways that he can spend his evening. The next example may be all of the same event, but they will have repeats. So an alarm system has a code that must be 4 digits. The digits, which are 0 through 9, can be picked more than once in the code. How many different codes are possible? So if we have here 4 different events occurring. Each digit represents a different event. For my first number to be picked, you have 10 options, 0 through 9. So you have 10 options of being picked. On my next digit, you still have 10 options to be picked. And that's going to be true for all 4 numbers. So each number represents a different event that's being picked. To find the total number of outcomes, you just go 10 to the 4th power. So there are 10,000 different possible codes of the lock. So if you were trying to break into someone's house, which you shouldn't do, and you wanted to keep trying the codes until you got it, you would have to test that code 10,000 times, 10,000 different codes until you for sure had it. The next type of counting principle is called a permutation. A permutation is an arrangement or ordering of a number of distinct objects. We're going to take a look at 2 different types of permutations. One where we have n amount of distinct objects and we're going to use all of those objects, and the other one is where we have n total objects but we're only going to pick a couple of them. So let's look at that first one. A factorial is to find the total number of arrangements where there are n objects and all n are being used. You just need to find what's called n factorial. So this right here means n factorial. What that really means, and you probably already know this, but if I had something like 4 factorial, you would just go 4 times 3 times 2 times 1 and calculate that out. So that would be 12 times 2 is 24. Okay, so an example of using a factorial says, if 6 people were to line up at a drinking fountain, how many possible lineups are there? So you have 6 people in line. 1, 2, 3, 4, 5, 6. And just thinking of this not in terms of factorial, just so you can understand the factorial, the first spot in line, there are 6 people that can be picked. Now, if one of the people's picked, now you only have 5 people for the second spot, 4 for the third, 3 for the 4th spot, 2 people to pick from for the fifth spot, and for the very last spot there's only one person. And using the multiplication principle, it says you just multiply each of those possibilities. Well, the other way to think of that is if I'm taking all 6 and using all of them, it's just a 6 factorial. So it'd be 6 times 5 times 4 times 3 times 2 times 1. Which ends up being here 720. So that means there's 720 different lineups for that. So NPR is really the main permutation. It is to find the total number of arrangements where there are n objects, but only r of those total objects are being picked, and the order the items are picked matter. You use this formula, n factorial divided by n minus r factorial. So let's look at an example. Alright, so the example says 10 students are running in a race. How many ways can the top 3 people finish? First, let's look at why this is an example of a permutation. First of all, you have 10 distinct students. They're all separate from each other. They can't be the same person. And then the next part is you are picking 3 of them, and they have to be all separate. You cannot repeat. That's what our distinct objects means, is that none of the items can be repeated. Alright, so that would be the first important thing about permutation. The next thing is that the order matters, meaning that there's a specific position to each of the outcomes. Alright, the first place is different than coming in second place. So you have the 3 distinct positions. So the formula wants us first to find n, which is 10. N will always be the bigger number. And then r, which is 3. You're picking 3. We're going to go 10 factorial divided by 10 minus r factorial. Now, once you get higher in this class, you will see that your calculator has all these operations, and you will be allowed to use your calculator. Alright, to calculate out this formula by hand, though, just so that you can see it, we have 10 factorial divided by 7 factorial. And the easiest way to reduce this is to take 10 factorial down to 7. 10 times 9 times 8. Then, at 7, both of these will cancel all the way out. So we end up with just 10 times 9 times 8, which is 720. So there's 720 different ways. So both of these types of examples that we saw are permutations without repetition. You can have a permutation with repetition, and that ends up just being the multiplication principle that we saw earlier. We're going to take a look at the last type of counting principle, and it's going to be very similar to a permutation. So let's talk about that now. So a combination is to find the total number of arrangements where there are n objects, but only r distinct objects are being picked. So exactly like a permutation. And the order the items picked are mattered, or do not matter. So that is the difference between a combination and a permutation. So let's take a look at a difference between combination and permutation. So if you had a fruit salad, and it has apples, grapes, and bananas. We don't care the order that the fruit are in the salad. So we would say that that salad is a combination of apples, grapes, and bananas. But if you had a lock or a safe, and you had the numbers 1, 2, and 3, it would be important to press those numbers in order. So that would actually be a permutation, not a combination, because 1, 2, 3 is not the same as 3, 2, 1. However, in a combination, they would be the same thing. Here's our example. In the U.S. Senate, which has 50 people in it, a committee of 4 people must be picked. How many different committees are possible? So our n here is going to be 50. So let's say n equals 50. And our r is going to be 4. So let's plug it into the combination formula, which would be 50 factorial divided by 4 factorial times 50 minus 4 factorial. This 4 factorial here really just divides out any of the repeated patterns. So it would divide out anything that was like 1, 2, 3, 4 and 1, 3, 2, 4. Those are considered the same in a combination. So the 4 factorial divides that out. So we go to calculate this. We get 50 factorial divided by 4 factorial times 46 factorial. And we will go and calculate that out. So if you go to calculate this all out, you get 230,300. That's supposed to be a 3. It just does not want to write. So there is a combination without repetition.